Okay, in this short demo presentation, we are going to go through the process of how to add a fingerprint to Praeda so that when it runs, even though you may not have any modules for it yet, we can at least identify it. We're going to show you how, after running Praeda, identifying a device within the web host file that's generated when it does the initial scan. And then we're going to go through the process of how do we go ahead and make modifications to the data list file using that information. Then we'll rerun it and you can see the actual results at that point. So first thing we'll do is we look here at the current folders and we have a results file. That results file is the output from a Nmap scan. Is it a GMap file that was generated when I scanned my local network? So we're going to go ahead and run this. We'll be writing the data out to a folder called oct29, and it'll be test one will be the actual log files that are actually generated. Let's go ahead and kick that off. Okay, that's completed running, and this is just the general output that you see when the device runs. And here it gives you some information and fingerprint data and just general data. Well, let's go ahead and look at some of the other files. So if we go ahead and go to oct29, from here we can go ahead and look at the test log, test1.log, and we can see that in here there is fingerprints for HP printers, fingerprints for this is a Konica printer, and we can also see there were several modules running for the Konica printer. But if we go back to the previous data, let's see if we can find it here, that dumped to the screen, we also see that there was a Xerox. Now it turns out that we can actually find that data under test1.web host, because this records all of that critical data, title page, header information, server file or server data on the device, and also SNMP, Simple Network Management Protocol, fingerprinting of the device, which we're actually going to use. So we cat that out, we see that we have a couple Xeroxes in here. So the way we would use this, since this Xerox happens to be SNMP data, so if we look at the structure here, this output, we have IP address, port number, the first section between 1, 2, 3, the third delimiter is the actual title page, web title page data will show up there if there is a title page. The next one is the header for the server type, and then the next one is Simple Network Management Protocol. So all of this is SNMP, but we don't need all of that. We need something that will be unique for this device. So we'll go ahead and capture that Xerox VersaLink C7025. We'll go ahead and copy that selection. And then we'll come back here and we will go to data. And we will VI the data list. This is the file contains all of the information. So we can see how this is done. So with these Xeroxes, we have a tracking number, identifier number, no big deal. It's just trying to keep some order in this file. Then we have the fingerprinting information, that SNMP data. Here we tag it as SNMP, and then we can just use the general purpose fingerprint, which is MPGP for that. So if we come down here to the end, and we just copy one, And let's go ahead and rechange that to 5. We go insert. And then we go insert colon. And remember, this particular one is MP GP. So it's a general purpose. So what it'll do is when the scan runs this time, each time it'll actually compare the data that's pulled back, whether it's S&P, server data. Say one above it as an example. This is actually pulling the server header. Seems like a lot of Canons have this. So this is a simple, non-specific fingerprint, but it just flags it as a Canon device. But this one actually has server. So it'll find Canon in the server return data, and it'll actually output that using this particular module, MPGP, which is the general purpose fingerprint module. And now we've created another, Xerox VersaLink C7025. It's going to be, get this right, that should be a pipe symbol. And there we go. And that should work. So we're going to write this out. And we're going to come over here to the Xerox. We're going to go ahead and I'm going to do this a little different. So let's go ahead and go back to the folder. And from here, we're going to run Praeda. And that's the syntax of Praeda, but we're going to actually go, we could use a target file, or we could do a CIDR. This particular case, we could do a CIDR /32. I think that'll work. /32 dash port 80. We'll just do 80 dash job is OCT 29, and our output log, we'll actually make that test 2. Let's see if we got the syntax right on this. So it instantly fingerprinted, and now we ended up with the results back. So now if we cat 29 test2 .log, we can see that it's actually writing the fingerprint out. But we're going to go ahead and we're going to do this across the whole system again. In this case, it'll run it for port 80 and port 443 because both of those ports are actually exposed. Okay, that's completed. So let's go ahead and look at the output. And cat test2.log. And from here we can see that now we have a fingerprint in there for the Xerox VersaLink 725. So it instantly notifies us that. So then we have a question. We've showed you how to actually just generically add a fingerprint on the device using the generic printer. Let's look at some of the other fingerprints that actually exist in the system. So let's go ahead and, because there's a couple in here. So we have this one here. This is in kind of a commercial or industrial printer. So it's a Zebra printer. So it's more of a commercial printer in that particular case. And I think we had some other ones over here like HP. Now the HP one was kind of unique. This was an HP, MP, HP. The reason why is a number of HP printers have a very ambiguous SNMP data string right here. You can't tell what HP this was actually, but it turned out that there was another MIB OID that gave more specific. But in the tool's normal functionality, it pulls a specific one that should affect every device in the world that has SNMP enabled for identifying it. They kind of hid themselves. And what we've done is we use this to initiate it, and then in the fingerprinting file for HP, we have it query that specific OID that gives more detail on that particular device. So that's a couple examples of those, and these files are fairly simple in nature. But let's go ahead and look at a couple of these so you can see this. We're going to look at a little bit of code. So if we go ahead and go VI, MP, GP, which is the general purpose fingerprint, we can see this is fairly simple. It's just a general purpose fingerprint. It goes through there. When this runs, it takes that little bit of SNMP, title page, server type, whatever you want, and it prints that out, letting you know what the device is. And of course, with most devices, it's fairly detailed. You know what printer it is. There's only a few exceptions to that. And then, of course, the industrial printer that we have in here, we often encounter some more commercial industrial printers like the Zebra scanner printers for printing barcodes and weird things like that. We basically use the same general purpose program format, but we just changed this out. So all it does is say, hey, this is a commercial printer, real quickly for identifying those type of printers. We got a little more complex when we start looking at the HPs. In this particular case, remember the HP's initial SNMP fingerprint data was ambiguous for a number of printers, and this is mostly some of the office jets and stuff like that, the low-end multifunction printers. But we're seeing a lot of those, and we're getting this generic. We want it to be able to fingerprint those, so we can hopefully take it to the next level and figure out how to write tools or modules for that. But again, it turns out that this OID gives us more detail. So when that generic information is returned and this particular fingerprint file is called, instead of just doing a standard output of that data, what it does is it does another device model OID lookup, pulls that data out, which is detailed, and it uses that for displaying what the actual device is. So that's a simple breakdown of some of the fingerprinting functions that we have on this device.